Already we were finished the projection of solid and section of solid. Now today we start the development of surfaces. As up to this section of solid and development of surfaces, there are some surfaces which are close. Okay. Now suppose if we have to cut the surface, and after cut, if we have to open, so how it look? If we have to see, then we have to develop it. Okay, so all the surfaces of the solids are open out on a plane surface, and the figure which is obtained are called as the development of the surface. Okay, if we see the some examples like sheet metal work, same way boiler and chimney. Okay, same way any kind of packaging boxes, which are the good example. And if we have to open it, then after cut, then what is the development that we can see very properly. Now there are mostly, as we know, that the solids are like cylinder, prism, pyramid, and cone. Okay, the solids are like cylinder, prism, pyramid, and cone. If we talk about the prism and pyramid, then there are all polygons like pentagon is there, square is there, square prism, pentagon prism, hexagon prism. Based on that, if we talk about the pyramid, then square pyramid is there, pentagon and hexagon pyramid is there. Okay, so based on that, prism and pyramid, and same way for cone and cylinder. Okay, if we have to develop these all things, then there are most probably two methods. The first one is the parallel line method, and second one is the radial method. I just give one example, so it's very easy for you to understand that what is the difference between parallel and parallel lines with the help of
But voice is not clearly.
okay, or in the prism. Now I just give one example, so it may be that what happened in the parallel line development. In parallel line, all types of prism and cylinder at where two parallel lines space at a distance equal to height, space at a distance equal to height of the object, and drawn at the sides of front view called stretch out lines. Okay, the length of the stretch out lines, which is equal to the perimeter. You remember that? How many length? It may be the perimeter of the object is drawn at the top and bottom side. If I talk, or if I just give one example, that I have a pentagon. Okay, I have a pentagon prism. Now I want to develop it. So what I have to do? Already I drawn the pentagon. Okay. After that, the height is given to. This is given. The dimension of the pentagon and the height of the pentagon prism is given to you. So as per given method, is the name A B C D E and 1 2. So based on that, I drawn the prism height whose height is 60 mm, where if I take the projection, then AB is there, so A dash B dash simultaneously here 1 dash 2 dash, same way 3 5, and it may be considered E dash D dash, and this is D, so D dash and 4 dash. Now we know that each side is 30 mm and the perimeter of the pentagon is 30 into 5, so it may be 150. So from this line, you have to manage some distance here and then take any random point and draw the 150 mm line, because it may be the pentagon. That's why. Suppose in place of this, square is there, so 30 into 4. In place of pentagon, it may be hexagon, then 30 into 6. So 180 is there. So right now it may be 150 mm, and the height already given to you. It may be given data, so not issue with the. Now give the name. If it may be prism, then A, B, C, D, E, as per the name suggest, A, B, C, D, E, and we know that whenever we have to close the figure, then first point is once again repeated at the end. Okay, so A, B, C, D, E, and E, A. And same way, 1, 2, 3, 4, 5, and 1. Okay, this is the center line. We know that the center line is between A dash B dash, sorry, A dash C dash and B dash E dash. So BC, it is between the BC. We are getting between the BC. So it may be here, right? And another is between A and E. So A and E is here. So yeah. So based on that, we have to give this center line. Now I just explain the radial line development. As the name suggests, radial line means most probably it may be useful for pyramid and cone. Most probably it may be useful to pyramid and cone. In this method, arc of radius, which is equal to the true length of the slant edge of the pyramid, or extreme generator of the concept develops of the their equation with percentage, and the equation is like this. Please remember the equation, very important, that theta is equal to small r by capital R into 360. Okay, theta is equal to small r by capital R into 360. You can see here the small r means the length of the object and the capital R means the slant height of the object. Okay, and based on that we are generate the angle. Based on that we are generate the angle means theta. Okay, oh, it is cone, so we have to generate the theta. Okay, now you can see here what we have to do. Suppose this is the triangle pyramid whose one length is 35 mm and slant edge is 60 mm. So what we have to do, first of all, draw the reference line XY, draw the front view and top view as per the given condition. It is given to you. Draw a horizontal projection line from O. Okay, draw a horizontal projection line from O in top view with O as a center, with O as a center and OC as a radius. And OC as a radius, draw an arc to intersect the horizontal line as shown in figure. Now, draw the vertical line from the point of intersection to meet the vertical plane at D dash. At D dash. ये जो vertical line है वो हमें उस तरह से लेनी है कि it may be equal to slant line. Okay, you can see here from O we are considered this C. Now from OC, after that we are take one arc and it is the maximum line. And after that we are just take the projection on XY reference line and then join this line. It means now this is the your length when you develop the pyramid. Okay. And angle is equal to small r by capital R into 360. ये angle कितना होगा? It may be as per the given equation. Okay. Now let's start one or two examples so it may be very clear in your mind. Draw the lateral development of cone of base radius is 20 mm and height is 60 mm. There is one cone. We know that the base of the cone is circle. So we have to first of all draw the circle whose radius is 20 mm. Okay. And height is 60 mm. So based on that, first of all draw the circle and divide that circle in either 12 or 8 parts as we have to do in the previous many chapter. Okay, so it's very easy for you. I start from 1 to 12 or 1 to 8, as it may be given to you 60. So from O as a center and extend from the reference line up to 60 and join with the last 2 point means edges, that is 1 and 7. So 1 dash and 7 dash, and generate the triangle. After that, take the projection of 212, 311, 410, 59, and 68, and extend on XY reference line, and it may be focus on O dash. So it may be our con. Okay. Now we have to develop it. We know that, as discussed previously in this figure, that in the triangle pyramid, O as a center and OC as a radius, and we take the projection. Why we have to do this thing? Because here this is not the maximum length. So on that time, slant length is very important, and to find slant length every time, either it may be triangle, square, or any polygon. So we are trying to do this thing where you can see here that O dash D dash is the true length. We have to find every time true length for pyramid, and with the help of this way we have to find. But in the circle, or we can say that in the cone, this is the maximum. Okay, so no need to find the true length, but every time we have to find the theta. How to find theta? Is equal to small r means 20 by 60 into 360. So based on that, you have to find this theta. After finding the theta, just as per the angle, suppose here 20 by 60 into 360. So 2 by 3 and 360 divided by 3. So 120 degrees there. So this is the 120 degree. And now you have to start. There are 12 parts. So each is of 10 degree, 1, 2, 3, 4, 5, 6, 7, 8, 9, 12, and 1. So based on that, it may be very easy for you to convert in equal part. Okay. And this is the development of cone. Previously, this is the development of triangle, development of simple prism, development of simple triangle pyramid, simple cone. Okay. Now start with the some example which are very important whenever we develop the any surface. I start with one or two examples very helpful to you. A cylinder of diameter 50 mm and length of axis 65 mm rest on its base. Okay, so you can see here as per the given data, a cylinder of diameter 50 mm. So initially we have to draw the 50 mm diameter means 25 mm length radius, and we have to draw this 65 mm length rest on its base. Rest on its base with the axis perpendicular to HP. It is cut by the cutting plane which is perpendicular to the VP and inclined at 45 degree to the HP. Every time the data is given in this way, most probably they are not provide the figure. So on that time, if figure is not provided to you, then you have to interpret your with your way that how to draw the cylinder prism. As per the data given, I have to draw the cylinder. Okay, so then we have to draw the prism whose length is 65 mm. I just extend all my points A, B, C, D up to L, and you may mention either with the dash or mention with the number. If possible, you may mention with the number, so it may be very helpful to you. Okay, so A, B, C, D, E, F, G, H, I, J, K, L, and here A dash to L dash, and same way here, wherever it may be cuts. It may be shown here that from the top portion, it may be from the center, it may cut below 25 mm and 45 degrees. So cut based as per the given instruction. Now, this figure, if not given to you, then the data itself provide you. As I mentioned here, the cutting plane perpendicular to the VP, the cutting plane perpendicular to the VP and inclined at 45 degree to the HP, and passing through the point on axis 25 mm from the top. Okay, passing from the axis and 25 mm from the top. So we have to leave 25 mm. Same way we have to draw 45 degree and we have to cut from that line. Now, we know that the periphery of this is a prism, so the periphery of this circle is pi into d, and d is equal to 50. So pi into 50, it is the total length. So as per the development, as per the starts of the development, we start with the first A, B, C, D, and end with the last L and then A. Okay, so our whole prism may be completed. Start from A, draw a number of surface line. So we can draw 12 and at the end one another. It may be the main line. So A is there. As the solid is here, as a solid is curve, so we have to draw sufficient number of generator. Now we give the proper number, we give the proper name in sequence. Now see, we have to extend or take the projection from one, whichever line it may be intersect with the cutting line, we have to take the projection. It may be cut at here initially, so take the projection, cut from this, fourth, fifth, sixth, and seventh. Now we know that this line may intersect on one, okay, and which may pass from A. So we have to draw first point, this A, and on A line and intersect with 1. Simultaneously, it may be at here also. So A and 1. Now it may be on B and L, right? So it is B point and L point. Now this is the C and K. So on C and on K. Same way J and D. So on D and on J. Okay, wherever it may be intersect, with the proper name and with the proper notation, you have to mention its name. Now 5, 9. So we know that 5 are on E and 9 are on I. So based on that, E and I are on 9. Now 6, 8, and then last one is 7. Join with the smooth curve. Join with the smooth curve. Complete the development and the projection by drawing appropriate conventional line for existing surface boundaries. So this is your development of a cylinder, or we can say the prism. Okay, whose diameter is 50 mm, whose length is 65 mm. It may be cut from the 25 mm and at 45 degrees. Okay, with the center. On that time, if you cut, then it may look like this. Okay. If you have query, then please mention in the comment box. So I will provide the proper answer also as per the queries raised from you. Now see, draw the development of lateral surface of the curved cylinder. मैंने थोड़ा complex लिया है, which may give the better idea about You can see the 20 mm is the radius, 55 is the length given to you. Now there is no any discussion about the data. The figure is given to you. So based on figure, you have to plan your whole figure. Okay. This is the center, and from the center draw the half circle. After that, from the bottom you have to take 20 mm, and then it may be touch with the end of the center point. Okay, so this is the cut portion which I indicate with the arrow. You can see here. So now we have to develop this surface. Now we have to develop this surface. As I discussed in the previous example, what we have to do? First, we have to do the projection line. We have to extend the projection lines. Kaise? We know that A, B, C, D, E, F, G, H, I, J, K, L, and the simultaneously 1 to 12 are there. So take the projection in the top view. Either it may be A or BL, CK, DJ, EI, FH, and G. Same way here 1, 2, 12, 3, 11, 4, 10, 5, 9, 6, 8, and 7. Okay. And we know that this is a pi into d. So take the dimension as per the periphery equation. So pi into 40, and whatever your dimension, based on that you take the length and convert in 12 equal number of parts. Now give the sequence, give the name in the sequence like ABCD up to L and A, and 1 to 12 and B. Now this is the A, so A is here and A is also here, and the last point G is at here. Okay, now it may also pass from this point where B and L is there. So B and L. Okay, just initially point out. Okay, आपको पहले सिर्फ पॉइंट से इंटरसेक्ट करना है, या यहाँ पे आए और यहाँ पे. So you just mention the point. You draw the lines from the concern division. Okay, after that it's very easy for you. So BL, now CK, C and K, then ZD, then IE, then HF. I just show you with F and L. And last one is G, and it is G, it is G. Okay. Now see. Yet this may be remaining. So we start to take the projection. This is the first point. So it may be here. Please mention the name as per the given figure. Okay. Either you may mention with the ABCD, or if it may be cut it here. So N1, N2, N3. Same way here P1, P2, P3 up to P12. Okay. It's up to you. So not the any confusion about the provide the name. P1, now it may pass from 2 and 12, so 2 and 12, then 3 in 11, 3, 11. Okay, same way for this and same way for remaining line. Okay, if you join all the points, then this is the line. I just show you the area. This is the portion which is the development of cutting. मैं जो इसका जब कट करूंगा ना, तो it may look like this. Okay, so development of cylinder is look like this. Okay. Now next one. It is an example of pyramid. It is example of pyramid. One thing you remember that only in cone we are not find the true length. Remaining where we have to find first true length when we solve the example of pyramid. A pentagon pyramid of base is 30 mm and height is 60 mm. So raised on the HP such that one of the edge of its base is parallel to and nearer to the VP. Okay, nearer to the VP and parallel to it. Okay. So first of all, we draw the inverted pentagon as per the given condition and complete the 30 mm pentagon and draw the pyramid. We know that this is a pentagon pyramid, so we have to find the maximum length either from this side or in this side. So O as a center and OA is the radius and arc here. So you are get the slanting maximum length. Okay. And height is given to that is 60 mm. So join all the points from the center point and take the projection here. So it may be A dash, it may be E dash, B dash, D dash, C dash. And all points are focused or concentrate on O dash because it's a pyramid. Now read the data once again. The pyramid is curved by a plane inclined to 40 degree to the HP at 35 mm on axis from the base of the pyramid. From the base, it may be 35 mm, and after that, from the middle point, it may be curved with the angle 40 degree, 40, right? So, as per the given data, we have to curve and we have to mention with the cutting line. Now, we will trying to solve the example and we will trying to develop the pentagon pyramid after cutting this line. Okay. Now let's start. See, it is a pyramid. So first of all, what we have to do, the equation is there that theta is equal to R by R into 360. So 30 by 60 into 360. So it may be 30 divided by 60 into 360, 30 divided by 2, 360, so 180. So almost this is the angle of 180 and it is a 5 side, so 180 degree and it may divide in 5 side. So it may be near to 36 degree. Okay, so it's almost 36 degree and based on that we are trying to cover whole development of pentagon prism. One thing you remember that whenever we develop it on that time, first of all we have to draw this and this last line and then using the curvature complete whole arc and that arc is वो कितनी होगी true length की जितनी, right, which we are find from here. So A double dash and this is the length, it is the radius from O. Okay, now each length is 30, so from A arc on the curvature, so A, B, C, it may be convert in equal number of part and join all the parts with this solid line. Now we have to start to draw the pyramid. To draw the pyramid, you have to remember one thing that each and every cutting line are extended on true length. आपको वो सभी points है वो true length पे extend करने हैं. Either this or this. And from point O dash or A dash, you may take the dimensions, you may take the or you may use the rotor where O dash is the center and this is the line 3 dash. So from O dash on 3 dash line means C dash line you have to arc. Same way 4 dash means D dash wali line. So on 4 dash we have to arc here from O as a center. Same way B dash, so 2 as a O dash as a center, and it may intersect on this way and 5. So we are getting from O dash and it may be E dash. So the line side is E dash. So 5 यहाँ पे cut होगा. Now last point O dash as a center and last one means A dash. So it may cut at here and here. Okay. Most probably in pyramid, we are joined with the help of scale. While in the prism, whenever it may be cut with the straight line or with the curve, then we are trying to draw with the smooth curve. Okay. So this is very easy example. I'm giving you the, yes. Okay. So I'm trying to cover today almost 3 to 4 example regarding development of surfaces. Now see one example that how to simply solve the example of development of surfaces. So it may very helpful to us.
India, time to help us out. From Itna Sara, I became this Sara. 96 to 56 kg.
Hey guys, what's up? This is Manas and it's going to be it goes like this: a pentagonal prism.
Please read the data very carefully. So it may helpful to you. अभी हमने ऐसा example लिया था. So it may be very easy for you to compare this solution of the previous example and current example.
40 millimeters, right? Now there is this condition that we've got to follow and which says that one edge of the base is parallel to and away from the VP. All right, so let's write this condition and we're gonna make sure that this condition reflects perfectly in the drawing. Now we have this cutting plane and let's write the cutting plane details, and we have this the angle made by the cutting plane that is going to be 45 degrees to the horizontal plane. It's an AIP, auxiliary inclined plane, and I've already told you that an auxiliary inclined plane is that plane which is perpendicular to the VP and inclined at a certain angle to the HP. All right, and that certain angle in fact in this problem is 45 degrees. That's exactly what I've noted down. And at the same time this cutting plane bisects the axis also. So that bisection point is going to lie 20 millimeters above the baseline or 20 millimeters above the XY line or the reference line. So all right, that's all the data that we have got noted down, and let's now get down to the business end and let's draw. So we're going to initially start off by drawing an XY line, a reference line, and we're going to start off by drawing the top view. Why are we drawing the top view? That question should strike your mind immediately. Now guys, I've already told you that this is resting with its base on HP. Now you should know this, that we are speaking of a pentagonal prism and it has a pentagonal base. So when it is resting with its base on HP, then one thing is for sure, that the true shape of the base can only be seen from the top, and hence we'll begin by drawing the top view first. Okay, and there is one more thing that we need to ensure, that is one edge of the base has to be kept parallel to this XY line, because in the question it has been said and mentioned that you need to keep an edge of the pentagon parallel to the VP. That's why we have kept it parallel to this XY line in this orthographic projection. Okay, now you know the internal angle of a pentagon is 108 degrees, and this is in fact what you call 20 millimeters. All right, so we're gonna go 108 degrees from here. Okay, and then we'll make one more line. This is again gonna be 20 millimeters. One more from here, 108 degrees, and then you can take this as center, put an arc of radius 20 millimeters, then take this as center, put again an arc of 20 millimeters. That intersection point has to be joined with this guy, and hence you're going to have this pentagon. All right, now this pentagon here has 5 corners, and let us say that this is 1 2 3 4 and 5. That's it. Now what we're going to do is we are supposed to make the front view eventually after this. All right, so we're going to look at this object from over here, that is from the front. Okay, and you're going to see these so-called projector lines. So this is going to be the front view over here. So this is going to be 1 dash, 2 dash, and this is 5 dash, this is 3 dash and 4 dash. Here they are. Now the axis length has been given as 40 millimeters. That's exactly what you're going to see from the front, the length or the height of the pentagonal prism. So it's 40. So let's go upstairs. Each and every point has to be elevated by an amount of 40 millimeters. Exactly, this is the axis, hence the representation is slightly different. A dashed dot line is used to represent an axis. So here we have it, the overall front view and the top view. Now let's get down to the cutting plane. Okay, so we have a cutting plane that is going to lie somewhere here, passing through this point. So this point is going to be 20 millimeters above from this baseline reference line. All right, so I'm going to make a point over here through which I'm going to make sure that a cutting plane passes at an angle of 45 degrees. All right, so let's make this horizontal line baseline. All right, and let's make sure that a cutting plane passes through this, okay, at an angle of 45 degrees. So that's the cutting plane. Okay, the representation is dash double dot. Remember this. Fine. Okay, now let's worry about the intersecting points of the cutting plane with the solid. Okay, so this edge over here from 1 dash, all right, is being intersected by this cutting plane over here. So that's going to be point A for you. And this edge over here from 2 is intersected at this height. This is going to be point B. And similarly, we'll have this point C, D, E. Okay, so let's write them down. Okay, so this is A dash, B dash, E dash, C dash, and D dash. Fine. Okay guys, now let's start developing this. Okay, and for that I'll be drawing extending this line from over here. All right, now let's start put up a point 1 over here. All right, now the distance from 1 to 2 is 20 millimeters, from 2 to 3 is 20 millimeters, and so on. Okay, so let's keep on naming them. What we'll be doing is we'll keep a scale over here. Okay, let's say 0 is here, then we're gonna put a point, a dot over here at exactly after 20 millimeters. Then again exactly after 20 millimeters we need to keep on putting those dots. All right, 2 3 4 5 and back to 1. So when you try to open a pentagonal prism, you're going to see 5 rectangles. Okay, and each of them will be having a base of 20 millimeters and a height of 40 millimeters, something like this. All right, so these are the 5 rectangles that I was talking about. Now let's move further. So we want this point, intersecting point A over here in the development. So we're going to use this parallel line method for that. So I'll be drawing a perfectly horizontal line from point A dash. So A dash is above 1. Okay, let's draw this. So this is going to be point A. This is again going to be point A. So let's write them down immediately. Point A, and here also we'll point A, something like this. All right guys, now we have this point B, and B is going to intersect exactly above this 2. Okay, above this 2. I'll draw a line. So this is going to be point B for me. Fine, let's move further. We have the point E. Okay, and E is going to intersect above 5. That's why I've stopped at 5. Okay, so this is going to be point E. All right, it's pretty easy. Development is a topic that's very popular among students because they find it very easy compared to projection of solids or section of solids or even projection of planes. And next we have this point C that's going to lie somewhere above this point 3 over here. Okay, let's draw a line from this point. It's going to intersect over here, and that's going to be point C for you. Fine. Okay guys, finally we have this point D. All right, so let's draw a horizontal line again, and it's going to intersect somewhere here. So that's point D for you. Now as far as prism development is concerned, all these intersecting points are going to be joined with the help of a straight line, and it should appear something like this: A to B, B to C, and finally everything is going to culminate at point A. Okay, so that's the development in this case of a pentagonal prism whose one edge of the base was kept parallel and away from the vertical plane, and at the same time this cutting plane was bisecting the axis. All right, so that's the development. and finally it should look something like this. All right, so I've written this down, 20 cross 5.
You have to darken the portion which may be cut, okay, like this, and remaining portion should be light, so it may very easy for you to understand. Okay, so you keep it in your mind कि आपको आप जब भी draw करते हो तो उस time पे जो भी portion cut किया है, it should be darken, remaining portion should be light. Okay, now one example based on pyramid, so it may very helpful to you that the difference between prism and pyramid you can easily understand. You remember one thing, that whenever we talk about the pyramid, on that time if cone is there, then the not required to find the true length. But when we have, whenever either a triangle, square, or any polygon is there, on that time we have to find the true length.
HP and bisecting axis. Draw the development. So the object in this case is obviously a cone having dimensions in the form of diameter. Base diameter is 50 and axis length is 60 millimeters. And at the same time, there is a condition that has been given to us, that is resting with its base on HP. All right. Now guys, just think about it. If a cone is resting with its base, that is a circular base on the horizontal plane, then one thing is for sure, that the true shape of the base can only be seen from the top, and hence you have to begin by drawing the top view of the base. All right, that's going to be, and that construction is going to happen below the XY line. Fine, let's move ahead and let's extract data regarding this cutting plane, okay, aka auxiliary inclined plane. That's what you call a cutting plane when it makes a certain angle with the horizontal plane, okay, and perpendicular to the vertical plane as well. The cutting plane is at an angle of 60 degrees, and at the same time it is bisecting this axis. All right, now after this what we'll need to do is, now guys, you need to think
192 countries की शान है.
about this. Now if you try to unfold the cone and flatten it up, okay, there is some kind of a pie kind of a portion which you're going to see. It resembles to that of a pizza. All right, and it is going to make a certain angle, and that certain angle has to be calculated, and we have this formula for that: 360 multiplied by the radius of base upon slant height. Radius of base is obviously, the base diameter is 50, so radius is going to be 25. Slant height can be calculated by using this Pythagoras formula. Okay, on putting the values we get this as our final answer, that is 138.5. okay, fine, let's move ahead and let's start the construction. As I've already told you, we'll initially start the construction by making the top view, and for that let's have a reference line, that's what you call the XY line, below which I'm going to place a dot. Now this dot is what you call the apex, okay, the top view of the apex, and this is represented by point O, and with this as center and with radius as 25, we're going to draw a circle something like this. Next step, let us provide some dimensioning to this circle. Okay, so this is 555 is our representation for diameter. Now let's divide this circle into 8 equal parts. Fine. Now let's start from this point over here, 1 2 3 4. Let's give all the points some names. Okay, so that's it, 1 2 3 4 5 6 7 and 8. Now guys, we have successfully drawn this top view, and now we want to create this front view. All right, and for that we have to look at this object right from here. Okay, so the front view of 1 is going to lie here, 1 dash, then front view of 2 and 8 are going to strike over here, that is 2 dash 8 dash. Similarly, we have 3 dash and 7 dash over here, we'll have 4 dash and 6 dash, we'll have 5 dash over here. All right, fine, let's write them down. Okay, now the axis height has been given to us. All right, and it's equivalent to 60 millimeters, so this is going to be 60. We need to go ahead, up ahead 60 millimeters, so this is going to be the axis. And now let us say that this point over here is the top, is the front view of the apex, that is O dash. Now let's join all these points, okay, with this apex. It should look something like this. All right guys, that's done. Front and top view done. Next thing to do is to locate the cutting plane. So how can we do so? We know very well that the cutting plane is intersecting, or rather bisecting, this axis over here. if a cutting plane is bisecting this axis, that one thing is for sure, that it is dividing this axis into two equal parts. That means 30 above and 30 below. So that is the point. And through this point, so this point actually is at a height of, from this point to this point, it's the height is 30 millimeters. All right. So from this point, we're going to draw a cutting plane, and it should look something like this. Okay, at an angle of 60 degrees. That's it. All right, guys. This cutting plane over here is intersecting the base, okay, as well as at the generators. This is also generator O3, O7. This generator is what you call O4, O6, and this generator over here is what you call O5. Okay, so we're starting from this point, it is cutting exactly at 2 and 8, and this is going to be A, this is going to be B. So A point is somewhere around O3, B point is somewhere around O7, then we have C, then we have D. C is somewhere around O4, okay. D is somewhere around O6, then we have this point also, that is going to be E. Fine. Now we need the true length. For development, we need true length. As I've already told you, you need to pick a generator. So right now we have as many as 8 generators, O1, O2, O3, O4, and so on. Out of these 8 generators, there is one such generator which is absolutely parallel to XY. So we can see clearly that O1 generator is absolutely parallel to this XY line, and hence its corresponding front view, that is O dash 1 dash, will show the true length. You can also say that O5 is also parallel to XY line. Okay, so O5 corresponding front view is also going to show the true length. So either you can take true length as O dash 1 dash or O dash 5 dash. Hence, so let's move forward. Okay, so the true length is O dash 1 dash, and let's move forward. Let's have a point A, big and bold, O point, and when with O dash 1 dash as the radius, and with this guy O as the center, I'm going to put up an arc over here, something like this. This angle is going to be, guys, 138.5, as we have already calculated. Okay, on flattening up the cone, the angle it is going to subtend at the center or at the apex is going to be 138.5. Fine, let's move ahead, and this is going to be the overall pi. Okay, and let's have this point as 1, and now we need to divide this cone, this particular section, into 8 equal parts. All right, it should look something like this, 8 equal parts. All right, so initially you saw this overall angle over here, 138.5. You can bisect this angle. Angular bisection is pretty simple. Okay, so when you bisect this angle, it gets divided into 2 equal parts. Then pick up any one portion, okay, then divide it further into 2 parts. So 1 can be divided into 2, 2 can be divided into 4, and 4 can be made 8. All right, that's how you need to go about your task. So these are all the division points, and let's name them one by one. This is going to be 2, 3, 4, 5, 6, 7, 8. All right, so we have all the points. Okay, fine. Now guys, we need to start developing this in the best possible way. You can clearly see that this cutting plane over here intersects the base at 2 dash comma 8 dash. So at 2 and 8. So let's make point over here, and let's make a point here. So this is the point where our development is going to start, and it's going to end at 8. All right, let's have the development for A and B. So A point is an O3 and B point is on O7. All right, so but for that, what we need to do is we need to project this A dash B dash onto the true length, and it's going to look something like this. So this new point over here is going to be A1 dash and B1 dash. All right, so now what you need to do is keep one leg of your compass here, other leg over here, then with O as center, you need to put an arc, something like this, and this is going to be your point A. All right, and again with that same radius, we need to again put an arc over here along this O7 over here. Okay, so you're going to have point B. Fine, so let's repeat this process for obtaining C and D. So C is going to be over here around 4, and D is going to be here, that is along O6. So let's extend the line, let's produce a line from C, and it's going to intersect this true length over here. So this is going to be C1 dash T1 dash. So again, keep one leg of your compass here, other leg over here, then with O as the center, put an arc 1 over here. So this is going to be your point C. Put one more arc over here, and this is going to be, guys, your point D. Finally, we have this point. So E dash is already on a true length, so doesn't matter. You can take this arc also. O dash E dash, or you can project it on the tooling. Okay, so this is going to be same. If you take it as O dash E1 dash, you also have the option to go for O dash E dash. Both of them, or both the arc lengths, or both the radiuses are going to be the same. Okay, now with O as center, you need to put an arc over here. Please watch carefully. So this is going to be a point E. All right, guys, only thing left is to join all these points in the proper sequence with the help of a smooth curve, and finally it should look something like this. So that's the development of the cone over here. And now finally I need to tell you guys which portion is to be darkened and which is to be left as it is. So initially all the drawing that we have made can be carried out with the help of a 3H pencil, and finally the portion which is to be darkened should look something like this, and it has to be carried out with the help of an H pencil. That's it. So this portion you see over here below the cutting plane, okay, has to be darkened. So this is the portion, all right, which has to be darkened. All right, guys, so that was all from my side, a 3H pencil, and finally the portion which is to be darkened should look at. So this portion you see.
Okay. I have the opportunity to request that please draw the and if you have query, then you may mention in the comment box. Okay. So regarding any query, you may ask me anytime, or you may mention in the comment box. So we will stop now regarding developer surface. Draw all the example, trying to solve all the example given in the either any book or in the given in any GTU exam. So I request के पहले एक बार draw करना. If you have query, then you may either mention in the comment box or you may directly mention in the personally to work any query regarding development of surfaces. It's very easy, but I request that पहले एक बार draw करो, फिर if you on that time if you have raised any query, then you can ask. And whenever you finish your all the sheets from next week, I will share one link. So on that link, you have either by me or by Hirpara sir, they may share one link. So you have to upload your all the sheets, including 1 to 9, including your AutoCAD and your loci points. Okay, so please ready all the sheets 1 to 9, and whenever we give, whenever we provide the link, you may upload on either Microsoft Team or wherever.